Keio University has established the Keio Future Photonic Network Open Lab to collaborate with domestic and international engineers for the research and development of next-generation optical network technologies. Supported by the Ministry of Internal Affairs and Communications, the facility serves as a base for industry-academia collaboration, enabling the sharing of cutting-edge technologies and the timely connection of research to real-life applications. In September 2023, optical cable installation work was carried out to introduce a new functional hollow core fiber cable and establish the world's first campus to be networked with hollow core fiber. Hollow core fiber is an innovative optical fiber with the potential to overcome the limits of conventional optical fibers. Because it can withstand light with an energy density over 1,000 times greater than ordinary glass core fibers, it can transmit multiplexed wavelength signals, power itself, and even analog signals without waveform degradation. It has garnered attention as a technology that will pave the way for revolutionary communication networks.
Conventional optical fibers have both core and cloth made of glass, and they confine and propagate light by total internal refraction realized by refractive index difference between core and cloth. Hollow core fiber is innovative for confining and propagating light in their core, which cannot confine the light by the conventional light confinement mechanism.
The first feature of hollow core fiber is that they can input and transmit very high power light. Secondly, the speed of light in the fiber is the same as in a vacuum, so signals can be transmitted 1.5 times faster than with conventional fibers. Thirdly, even when very strong light is input, it can be transmitted far without waveform degradation.
The recent construction connected optical cables using hollow core fiber to the buildings of the Future Photonic Network Open Lab, aiming to establish a huge resource pool interconnecting the CPUs and memories of each computer in the research labs.
We have 4 buildings in this campus. We have established an ultra-low latency optical network through the campus by connecting 4 buildings with newly structured hollow core fiber. This is the world's fastest achievement.
Open laboratory of hollow core fiber transmission experiments closely replicates real-world practical conditions such as inside manholes. It's probably a world-first facility, and we consider it as an innovative challenge.
We have the facilities that allow us to conduct experiments at our open lab with the hollow core fiber. For example, we can do the real 5G access network experiments using our local 5G network, or experiments of some application like an autonomous driving vehicle or real haptics.
Various other application experiments are being conducted using hollow core fiber, including the development of network-controlled systems that synchronize time and space on computers, such as those in ultra-compact vehicles for autonomous delivery and self-driving cars.
For example, it can be used where high-speed commercial transactions take place. There, the relations need to be fast, such as receiving information as quickly as possible and placing orders in line with stock prices and other information. Hollow core fibers are useful where delays 1 millisecond or 1 microsecond can make the difference between winning and losing.
Hollow core fiber can transmit 1,000 times more energy than conventional fiber. It's called power over fiber. And if this can be realized for sensors and cameras in remote locations, it is possible to send both signals and energy via single fiber without a power cable.
The hollow core fiber can transmit analog signals because of the high linearity. In future local 5G system, radio waves are transmitted between the base station and the antenna By the analog radio over fiber technology, it is possible to install the antenna in the shadows of buildings or other places where it is difficult for millimeter radio waves to reach. Furthermore, research is underway to use optical switches to select the antenna that blows radio waves.
Its transmission characteristics are also advantageous for other telecom applications, such as access network and long-distance transmission. So we will keep improving this technology in order to apply in various communication fields in the future.
Through Keio University's Future Photonic Network Open Lab, we are creating the startup company which is active in the United States. There are many large corporate research laboratories in this area, and we hope to collaborate with them to make this area of the center of the new optical technology to the world.